So in this example, this is something really important to understand because you guys kind of going through the motions, right? We've been kind of doing the same thing, Carlson, over and over and over again. So you get to this point and you say, all right, I get it. U is going to be plus 1. Du is going to be equal to 2 dx. And then you kind of realize you're saying, all right, well, there's no 2, so I get it. I can rewrite the 1/2 there. I kind of understand that. But there's a bigger problem, right? There's something else that's there that we have not accounted for. Does anybody see this little thing, this extra alien here? This x. We don't have anything accounted for x, do we? Right? So if this happens, or if this is the case, we need to represent x in terms of u, right? Everything has to be in terms of u. So let's go back to our u equation. And let's rewrite x in terms of u. So subtract 1. And I had this as, yeah. So I wrote it just like that. So that is represented by x. Now, when I go back to rewrite my equation in terms of u, I am going to replace, so I have my 1/2. I'm going to write my u as u minus 1 divided by 2 times the square root of u du. Now let's make sure, is everything covered? It'd be really important for you guys to be paying attention on this one. We have our x covered. We have our dx, which is equal to 1/2 du. We have the 1/2 in the du. And we have the square root of our u. So we're looking pretty good, right? Now, the main important thing that we have to understand in this case is if we're going to integrate this, we're going to want to simplify this, right? So we're going to want to rewrite that to a rational power and distribute it. So we could rewrite this as, I'm kind of running out of space here, but 1/2, I could do u minus 1 over 2. So I rewrite that as 1/2 du. And then I would distribute that to both those terms. So therefore, and actually what I could do is let's divide that out. I could take this out as well. Actually, let's rewrite it like that. I could pull out that 1/2 and do u minus. Does everybody see how I kind of took out the 1/2? Then I could take out the 1/2 one more time. This 1/2, that's another constant. I could take it on the outside. So therefore, that's really 1/4 integrate u to the 3/2 minus u to the 1/2 du. Just adding with my rules of exponents. No? Yes? Now, is this much easier to integrate? Yeah, you just integrate each one separately. Correct? So I'll keep my 1/4 on the outside. Add 1, which would be 2 over 2, which would be 5/5. So do u to the 5/2, and then multiply by 2/5. And then minus, add 2 over 2, which would be 3/2. So divide by 2/3. Actually, I don't really want to. You can add that as your, I guess, as your plus c. Yeah, it doesn't really matter if you add 1/4 times plus c. And then we could distribute that or leave it just like that. I'll just leave it like that. OK.